Hello TAs, Chimichanga here. Today I'm going to explain how you can explain to the students what means and standard errors are. So let's start out with two number lines like this. And let's make these number lines so that they have the same tick marks. Now let's sample two species, and these two species will have sample sizes of 20. So let's say there's 20 little data points in here. 4, 5, 6, 7, blah, blah, blah. I'm not actually going to draw 20, but you could imagine that there would be 20 data points in there on top of each other on that number line. And this is for species A. And then for species B, there's also 20 data points. And they're kind of on top of one another and so on, like that. And that's the situation. So now we want to calculate some statistics for each of these distributions. And you can kind of imagine that each of these distributions is in the shape of a bell-shaped curve. And what we want to do is we want to calculate the average for each of the distributions and then the width of distribution, which is called the standard deviation. So we want to get the means and the standard deviations. The mean is equal to each of the values of the items. So let's say they were weights, each of them, and then we add them all up and we divide by the sample size. So that's equal to the mean, which we call y bar. Y bar. Everybody knows this. This is called the average or the arithmetic mean. And then we also want to calculate the width of the distribution, which can be indexed by the standard deviation. And what's the standard deviation? You take each of these y's, so each of the 20 in each case, and then you subtract y bar and square it, and then take the sum of all of those things. So it's the squared deviations from the mean divided by n minus 1, which is kind of like averaging it. And then you have, because you took the square, you have to take the square root. So do like that. So that's the standard deviation of the items. Now we don't just want the standard deviation of the items. The standard deviation of the items is how wide this distribution is. But what we really want is to know how reliable the mean is. How reliable is this mean? Now this mean is just based on 20 data points, and we would really like to know whether it's a little bit off or way off and stuff like this. So mathematicians have figured out that we can index the reliability of that mean with something called the standard error. And the standard error is equal to the standard deviation divided by the square root of the sample size, like that. And what is this standard error? Well, it's imagining that we did the study a very large number of times. Let's say we did it 1,000 times, and each of 1,000 times we got 20 of A and 20 of B. And each of those 1,000 times we calculated the average of A and the average of B. Now those 1,000 averages would vary from one to the next. They wouldn't be exactly the same. And what this standard error is it's the standard deviation of the means. So you have 1,000 means, and they have a little bit of wobble to them. And so how much wobble do they have to them? Well, the standard deviation of those 1,000 means is the standard error. And so we usually then calculate that and display it. Say we start it all over again, where we have A and B, and and of course they have tick marks that are all lined up like that. And then the means are calculated. So here's the mean, and then here's its standard error up and down. So plus 1 standard error and minus 1 standard error. And then here's another mean for species B, up and down like that. And so that's basically what we want to graph. Now, we don't really have to do the second number line because it's exactly the same as the other number line. Like that. And then this square has its little number line on it, like that, and then you have species A and species B, that, and let's say A and B. And then the question is, do these error bars overlap? And if you can fly a little airplane in between them horizontally, then they don't overlap. And that's taken as an informal way of believing that there's a real difference between species A and species B. Okay, we'll pick this up with some real data. So we have sort of standard Scleropodium obtusifolium, which is a moss, and then we have a possible new species of Scleropodium. And somebody went and measured the leaves of these Scleropodiums. They measured the length and the width of a leaf on this specimen and the length and the width of the leaf on another specimen. And so we have a bunch of specimens of both possible species. So we want to see how much they differ and whether we believe this difference is real. Plants vary in how big they are, so length by itself or width by itself we suspect is not that great, but maybe the width to length ratio is useful. So first we'll calculate that, and we do that by pressing equal sign and then clicking on width and then divided by length like that. And you can see the formula, then we'll calculate it. We can then copy that formula down for all of those specimens and copy it over here for all of these specimens. And if I did it right, when I click on this, it'll highlight what I'm using to divide by and so on. So I think I did it right. Now I want to calculate the mean or average for each of the two species, so I type equal sign average, and then I can drag on all of the specimens that I want to average. So all of the specimens of Scleropodium obtusifolium, and see it calculates it, which is very nice. And then I want to calculate the standard deviation of all of those specimens. So I do equal sign STDEV for standard deviation. Again, I drag on all of the numbers and close parenthesis. And then for the sample size, it's count, so equals count. And I want to count the number of specimens. There, like that, close parenthesis, and it's 15 specimens. And then I calculate the standard error of the mean, and remember that's equal to the standard deviation divided by the square root of the sample size, like so. Now I want these same statistics for the other species, so I can copy it and then paste it over here, and if I did it right, it should be giving me things correctly. So let's just check here. The average come out right. Yeah, so everything's good. So now I have the statistics. I want to move on and graph those statistics, but they're kind of, at least to my mind, in an awkward place. So I want to try to change where they are. So I'm going to copy them over like this. and then I'll just paste special here. So I click there, I go up to here, edit, paste special, and I want to transpose them, so make columns rows and rows columns, and then I only want the values. I don't actually want the formulas. So I'll click on that and kind of cleans it up a little bit. New species. Then I don't need these lines in here, so I can delete them, which is just Control minus. I actually don't need the standard deviation and the sample size really either, but I can just leave them there. I could delete that, but I think it's okay. So then I highlight the numbers I initially want to graph like that, and then I'll insert a chart. So go like this, and I want a column chart, just like a regular simple column chart like that. So, okay, there's a lot of mess, and we can start cleaning that up. So maybe the first thing to do is to label the axis. And so if I click on, this will be different for each version of Excel, but I want axis titles here, vertical, and then, yeah, probably like this one. Let's try this one. And that is the width to length ratio. And then I don't really like these lines. These lines are okay, but I think maybe a whole square would be nice. And so I'll click on the middle of that and maybe control click, format plot area, and have a line. We'll make it black. Let's see what that does. That made it a little bit better. Now the outside line here I don't really need. So outside of the graph here, I'll control click on that and format chart area. And there I don't want a line at all, so I'll say no line. I also don't need this series business at all. Now I want to have error bars that go up and down to show the standard errors. So I click on the bars there, and then I go up here to error bars, and I want, don't use this. This is some kind of old thing from past Excel that doesn't make any sense. So go error bar options. Oh, here, click on error bars, and we want custom error bars. Specify the values, and then we can drag on the numbers we have here. You want to do this both for the up and the down bars. And hopefully that'll work. Let's see what that does. Yeah, so it made some nice error bars. Now, we don't really need to start at 0 because 0 width to length ratio doesn't mean anything to me or to you. It looks like we could start at 0.5 maybe. That would make sense. So let's have the minimum here be 0.5, and then we also want the horizontal axis to cross at 0.5. So let's see what that does. Yeah, that does it a little bit nicer. We're starting to get there. Let's see. This, I think, could be bigger. So let's go up to 12 point, and then not make it bold. I don't think it needs to be bold. And then these things I think also should go to 12 point. Make it a little bit better. Yeah, that's nice. Okay, now with each graph you also have to have a caption. And so we can write our caption someplace. Let's just insert a text box and do that. So I'll go insert text box, maybe right here, and I'll say figure 1. Means and standard errors comparing two putatively distinct species of Scarpodium. Well, let's write n equals 15. That's the sample size. And then you can write a little conclusion there. So since the error bars do not overlap, I believe the species are different in their width to length ratios. Yeah, something like that. And then you can have your students just turn this whole thing in, and then you can have a look at it and see if they did it correctly. The most common error is that they don't get the error bars using their actual numbers. That's all I have to say about that. Good night and good luck.